Good afternoon, dear students. Yes, very good afternoon. Yeah. Okay, so today we are going to start with the PU first chapter. Okay, biomolecules. Tomorrow I'll be doing. So I know yesterday's class. Okay, biomolecules. So the last chapter from PU or that is second year. Okay, so that I'll be dealing in tomorrow's class. So today we'll complete basic concepts of chemistry. Okay, so I hope you have gone through the synopsis. Yes, so shall we start the MCQs based on this chapter? Okay, so this is the first question. Two samples of lead oxides were separately reduced to metallic lead by heating in a current of hydrogen. The weight of lead from one oxide was half the weight of the lead obtained from the other oxide. The data illustrates law of reciprocal proportions, B, law of constant proportions, C, law of multiple proportions, or D, law of equivalent proportions. Yes. So what does this law states? So there's two samples were given, okay, of lead oxides, and these were separately reduced. Okay, they were separately reduced. So from your lead oxide, suppose I write it as so lead oxide, okay, is converted into metallic lead. So what is the weight of the lead from one oxide? Okay, so the weight of the one oxide, so two samples were taken. Okay, now two samples, so one weight of the lead from one oxide was half. Okay, and the weight of the lead which was obtained from another. So if this was 1 kg obtained, so this was half kg. So what is this data? Okay, what it illustrates? Which particular law it illustrates? Okay, Vamshi Krishna has answered as C. Neeraj has answered it as A. Madan has answered it as C. Okay. So the answer is C. Okay. So the answer is C. So here, so we know that what is law of multiple proportions. So if two elements, okay, if they form, so if there are two elements and they form more than one compound, okay, then the ratio of their masses of the second element will combine with the fixed mass of the another first element, okay, and it will be the ratio of in the small whole numbers. So this is multiple proportions. Okay, it depends on what? It depends on the multiple proportions. Fine. So it depends on the law of multiple proportions. So that is option number C. So what is the law of multiple proportion? I have told you. Okay. So this fine. So in one, the metal that is a metal obtained is half. In another, it is other. Okay, but these are what the two metals they are forming what they are forming corresponding oxides only. Okay, these oxides are what they are done. They are reduced to corresponding metal that is lead. Okay, and their ratios are different. Okay, ratios are different. So this is with respect to what? This is with respect to multiple proportion. Okay, let us go for the next one. The weight of one molecule of a compound C60H122 is. the weight of one molecule of a compound C60H122 is. So we have to find the weight means what? We have to find the molecular weight. Okay. So molecular weight of C60H122. So what is carbon? So carbon is 12 into 60 plus hydrogen is 1. Okay, hydrogen is 1 into 122. How much it comes? 60. This will come to 842. So now what we have to find? We have to find one molecule of a compound, right? So therefore, weight of one molecule is how much? Molecular weight of C60H122 divided by, you have to multiply it by what? Avogadro's number. Okay, Avogadro's number. So 2 by 6.023 into 10 raised to 23. See what will be the answer? Okay, Madan has answered it as B. So they have told you to find one molecule of compound. So whenever one molecule, one mole is asked, so you have to multiply, divide it by the Avogadro's number, right? So see how much you are going to get. What will be the answer? Only Madan has answered. Others, yes. What are you getting? So do 842 divided by 6.023. The answer I am getting is 1.4 into 10 raised to minus 21 grams. That is option number B. Yes, everybody else has also got the same. Okay, Neeraj has also got the same. Others? Yes. Okay. So let us proceed for the next one. Okay. So like this is to be solved. With increase of temperature, which of this changes? Okay. With increase of temperature, which of this changes? A, molality. B, weight fraction of solute. C, fraction of solute present in water. And D, mole fraction. Yes, with increase in temperature, what will change? Molality, weight fraction of solute, C, fraction of solute present in water, and mole fraction. So Madan has answered it as C. Vamshi Krishna has also answered it as C. Yes. Okay. So we know that. Okay. So we know that. Okay. Volume. Okay. So when you increase the temperature, okay, if you increase the temperature, what will happen to volume? If you increase the temperature, what will happen to volume? Volume also will increase. Okay, volume will also increase. Now, if some water molecules are present, okay, if some water molecules are present, what will happen to the water molecules? They will get evaporated. Okay, so some of the water molecules, what will happen? They will get evaporated at high temperature. Right. So option number C is the correct answer. So what happened? So as the temperature is increased, okay, as the temperature is increased, what is happening? Volume is increasing. So as we know, as we are increasing the volume, okay, as the volume is increasing, suppose water is there in a beaker or a vessel, and I am heating it. So what will happen after some time? This water molecules, it will start getting evaporated, right? It will get evaporated. So it is option number C. So with increase in temperature, what will happen? The fraction of solute present in the water. Okay, fraction of solute present in the water. So yes, so this is the answer. Let us go for the next one. The empirical formula of a compound is CH2. 1 mole of this compound has a mass of 42 grams. Its molecular formula is. So empirical formula is given. So let me write what all is given. Empirical formula is given. Empirical formula is CH2. Okay. Then molecular formula is given of the, that is molecular mass of the compound is given. Let me write not molecular formula. Molecular mass. Molecular mass of compound is given, and what is the molecular mass of compound is 42. Okay, so we know that what is N? N can be calculated. N can be calculated as molecular mass divided by the empirical mass. Okay, so what is molecular mass is 42. Okay, and what is the molecular this empirical mass of the CH2? Empirical mass is carbon is 12, hydrogen is 2, so it is 24. Okay, so into two hydrogens, right? So it is how much? So just see how much you'll get. So 12 plus, sorry, 12 not into 12 here, carbon plus two hydrogens. Okay, so 12 plus 2 is 14. Okay, into 14, not 24, sorry. So in by 14. So just see now 14. 3 4s are 12, 3 1s are 3. Yes, 14 3s are. Okay, so N is equals to 3. N is 3 here. Now, what will be the molecular formula? So we know that molecular formula is equals to N into EF. Okay, so N is 3, EF is CH2. So it is C3H6. Okay, C3H6. Are you getting the same? Okay, Madan Vamshi Krishna has answered it as A. Yes, A is the correct answer. Okay, A is the correct answer. Got it? Is it clear? Shall we move to the next question? Is it clear? Okay. 50 ml, 10 normal H2SO4, 25 ml, 12 normal HCl, and 40 ml, 5 normal HNO3 were mixed together, and the volume of the mixture was made 1000 ml by adding water. The normality of the resultant solution will be. Yes, Madan has answered it as B. So whenever we are calculating normality and we have how many solutions? So this is 1, this is 2, and this is 3. Okay. So we have 1, 2, and 3 normal solutions. So 3 normal solutions. So that time, how we can find out the resultant? We can find out by N1V1 plus N2V2 by N3V3. Okay. By the total volume. Okay. So we can do like this. So N1 is what? N1 is 10 normal into 50 of first. Then second is 12 normal into 25 plus 5 normal into 40 divided by what is the total volume? What total volume is? 50 plus 25 plus 40. 100 and so total volume. Okay, the total volume of the solution. Okay, it is said here. Total volume of the solution was made 1000 by adding water. Okay, so to that solution 115, remaining was water molecule added. Okay, water is added, so it becomes 1000. Okay, it becomes 1000. So see now how much you are getting. Yes, answer. Neeraj has got it as B. What about others? 50 into 10 plus 25 into 12. So it is 1 normal. So it is B. Are you getting the same? Yes. Okay. Is it clear? Yes. Okay. So the answer is 1 normal. Yes. The answer is 1 normal. So we get what? 1 normal. Okay. So units are important. So here normality we are finding. So it is 1 normal. Okay, let us go for the next one. The Statue of Liberty is made of 2.0 into 10 raised to 5 lbs of copper sheets bolted to a framework. 1 lb is equals to 454 grams. How many atoms of copper are on the statue? So atomic weight of copper is 63.5 unified mass. Okay. So you have to calculate how many atoms of copper are present on the statue. So how we are going to use? So yes, try to solve this bit applicative type of question. Vamshi Krishna and Neeraj have answered it as B. Okay, only two answers I've got. So let me solve them. So now we know that. So what all is given? Okay, we need to write the given things. So given is the mass of copper is given. So mass of copper is how much? Mass of copper is 2 into 10 raised to 15 lbs. Okay, that is 2 into 10 raised to 5 into lbs is how much? Each one lbs is 454. So I will multiply this. I will multiply it here only. So lbs value also 454 grams. Okay, into 454 grams. Now, next is what? We have to find the molecular weight of copper. So molecular weight of copper is given. It is 63.5 gram per mole. Okay. Then we'll calculate number of moles of copper. What is number of moles of copper can be calculated as the given weight upon the molecular weight. What is given weight? Given weight is 2 into 10 raised to 5 into 454 divided by 63.5. Okay. Therefore, the number of atoms on the same on the statue will be how much? So we have to calculate what the number of atoms of copper on the statue. So what we have to do? We have to multiply it by Avogadro's number. Okay, 454 divided by 63.5 into Avogadro's number is 6.023 into 10 raised to 23. Okay, so I'll write it here. Into 10 raised to 23. Okay, so calculate this and see how much you are getting. So let me see. So 2 into 454 divided by 63.5 into 6.023. So it comes to 86 something, 86 point. So 10 raised to 23. So if you shift this side, so it becomes, so it is 8.6, this. Okay. So 2 into, see here, 2 into 54 divided by 63.5. So this comes to 14.299 into 6.023 into 10 raised to 23 into 10 raised to 25. So this is how much you are getting into 6.023. Okay. So this is coming to be 86.12 into 10 raised to 23, 24, 25, 26, 27, 28. So 28. So what if I shift this side? So it becomes 8.6 into 10 raised to 29. Option number B. Are you getting the same? Yes. Vamshi Krishna, Neeraj and Madam have answered it as B. Very good. Okay. Is it clear? Others? Others can also answer. Yes. So try to answer the questions. Okay. So let us go for the next one. The empirical formula and the molecular mass of a compound are given. What will be the molecular formula of the compound? So we have solved like this. So one more question based on that. So what is given? Empirical formula is given CH2. Molecular mass is given 180. So N can be calculated as what? N can be calculated as molecular mass divided by empirical mass. Right. Now, what is molecular mass is 180. What is empirical mass is 12 plus 2 plus 60. So it is 30 divided by 36. So N is what? N is equals to 6. Okay. Now, so put that value. So so molecular formula is equals to EF into N. Okay. So this is the formula C6 H12O6. Are you getting the same? Yes. Madan and Neeraj have answered as B. What about others? Yes. Yes. Other students try to solve. Guess and answer. Don't sit idle. Okay. So you should also answer so that I'll understand you have understood the things or no. Okay. So let me go for the next one. What is the mass percent of carbon in carbon dioxide? So calculate the mass percent of carbon in carbon dioxide. How do we calculate? Yes. Okay, Madan has answered it as B. Mass percent of carbon in carbon dioxide. So what is the mass of carbon is 12. Carbon dioxide is 12 plus 60. 44 into 100. Do this. 12 by 44 into 100. How much you're getting? 12 by 12 divided by 44 into 100. You have to get 27.27%. Are you getting B? Yes. Bhuvan has answered it as B. Then Nandan. Okay, Nandan. Neeraj, Chaitanya. Yes, very good. Yes, B is the answer. The number of gram molecules of oxygen in 6.02 into 10 raised to 24 CO molecules is the number of gram molecules of oxygen in 6.02 into 10 raised to 24 carbon monoxide molecules is. Okay, Madan has answered it as B. Okay, Neeraj has answered it as B. Bhuvan has answered it as A. Okay. Others? So 6.02 into 10 raised to 23 is what? It is the Avogadro's number, right? 6.023 into 10 raised to 23. So this much molecules of carbon monoxide is what? It is 1 mole, right? It means 1 mole. So 1 mole of carbon monoxide means 6.23 into 10 raised to 23 molecules of carbon monoxide. So this is Avogadro's number. So whenever we are calculating 1 mole means you have to consider it to the Avogadro's number. Now 6.02 into 10 raised to 24 molecules, that is carbon molecules of CO is what? It is equal to how much then? So it is 24, right? So it is into 10. Okay, so it is 10 moles of carbon monoxide, which is equal to 10 grams atoms of oxygen, okay, and 5 gram molecules of O2. Okay, so it is option number B. Option number B. So 6.02 into 10 raised to 23 molecules of carbon monoxide is 1 mole. So for 6.024 into 10 raised to 24 molecules is how much? Okay, if you do like this, so if I do cross multiplication, so 6.024 into 10 raised to 24 divided by 6.02 into 10 raised to 23. So what will happen? It will be 10 raised to 1. That is 10 molecules. So 10 moles of carbon monoxide. 10 moles means 10 grams. So 10 grams of oxygen. Oxygen atom. Okay. We are converting into oxygen molecules because we are asked number of gram molecules. So oxygen molecule means 2 oxygen atoms will make 1 molecule. So it is 5 grams. Okay, 5 grams of oxygen molecule. So it is B answer. Is it clear? Okay. So the molecular weight of oxygen and sulfur dioxide are 32 and 64 respectively at 15 degree and 115 mm Hg pressure. 1 liter of O2 contains N molecules. The number of molecules in 2 liters of sulfur dioxide under the same conditions and temperature and pressure will be. So we should apply which law here when we are considering the temperature, pressure? Yes, it is the Avogadro's law. Okay, now we know that according to Avogadro's law, okay, equal volumes of all the gases, equal volume of all the gases, what it contains? It contains equal number of molecules, right? Under same temperature and pressure. Okay, the condition is same. So that time so if 1 liter, suppose if 1 liter, if 1 liter of one gas, okay, if 1 liter of one gas, if it contains N molecules, what it contains? If it contains N molecules, then 2 liters of any gas under
ಬರ್ತದೆ.
Okay, so if for 2 liters of any gas under the same, okay, will contain how many? 2 normal molecules. So this is what? This is according to the Avogadro's number, Avogadro's law. What is Avogadro's law? Equal volume of all the gases under similar condition, they contain equal number of molecules. So what is the condition? The condition is that the temperature and pressure should be same. The temperature and pressure should be same. So what is the answer? Option number C. Yes, Vamshri Krishna, Neeraj have answered it right. It is option number C. Okay. Understood? So we are applying here what? We are applying Avogadro's law. What we are applying? Avogadro's law. Okay. Let us go for the next one. The percentage weight of Zn in white vitriol is approximately equal to. So the atomic weights are given. How do you calculate the molecular weight first? Molecular weight of vitriol is ZnSO4.7H2O. Okay, so calculate zinc is 65. So first you have to find the molecular weight. So we have to percentage of zinc, right? So how do you calculate percentage of zinc? By the molecular weight of zinc, that is the compound zinc. Okay, zinc vitriol, that is zinc sulfate dot 7H2O into 100. So we have to calculate this also. So 65 plus sulfur is 32 plus 4 into 16. Okay, plus 7, 7, 2 sevens are 14, right? So 14 hydrogens plus 16 into 7. Calculate. So after calculating this, the molecular weight of ZnSO4.7H2O, it comes to what? It should come to 278. Calculate. See, are you getting the same? 278. Now, percentage of zinc. Percentage of zinc. Zinc is what? 65. Divided by 287 into 100. Calculate now this. See here, everything is given. Zinc is how much? 65. Do simple calculation. Zinc is 65. Okay, so 65 plus 32 plus 14. Okay, plus 4 into 16 plus 16 into 7. Yes, I got it, 287. Yes, Shri Krishna has answered. He has got the answer as 22.68. Okay, let me see. 65 divided by 287. Yes, it is 22.64. Okay, I'm getting 648. So it is nearly equal to D. Yes, are you getting the same? Other students? Yes, Neeraj has got it as D. Others? Vamshi Krishna has also answered it as D. What? Yes, other students? Are you solving? Yes? Please answer. Yes. Okay. So, this is the way you are solving the questions. Okay. So, let us go for the next one. Liquid benzene burns in oxygen according to the equation. How many liters? So, this is the equation given. How many liters of oxygen at HTP are needed to complete the combustion of 39 grams of liquid benzene? So, the molecular weight of oxygen and C6H6 is given. So how much liquid benzene is burned, okay, in oxygen? So this is according to the equation. Yes, see how much liquid benzene is burned. So C6H6 plus oxygen, okay, it burns in oxygen according to the equation. So how many liters of oxygen at HTP are needed to complete the combustion of 39 grams of liquid benzene? Yes, how do you calculate this? So let me write the equation. So 2C6H5, okay, plus 15O2. So this is gaseous, giving you 12 carbon dioxide gaseous plus 6H2O gaseous. Yes. So this is how much? 2 into molecular weight is 78. This is 15 into 32. Because it is an oxygen molecule, right? So since so 78 into 2, 2 it's the 16, 14, 15. So since 156 gram of benzene, okay, for 156 gram of benzene according to the equation, okay, it required how many oxygen? It required oxygen is how much? It required 15 into 22.4 liter. Okay, it required 15 into 22.4 liter because it is a standard temperature pressure. So we have to multiply it by what? The standard this, okay, 22.4 liters. So for, therefore, 1 gram of benzene, so 1 gram of benzene, required oxygen, how much it is? Yes, so for 156, it is 15 into 22. So for 1 gram, how much? So 1 into 15 into 220, this divided by 156 liter. Yes. How much are you getting? How much are you getting? Just see. One into 15 into 22.4 divided by 156. Okay. So here, so this is for, we have calculated for 1 gram. Okay, so this is for 1 gram. Now what they have asked, how many liters of oxygen at HTP are needed for 39 grams. Right, so what we can do here only, so therefore 39 gram of benzene required oxygen is how much? It is 15 into 22.4 divided by 156 into 39. Now you check. Now you will get the answer. So how much you are getting after solving this? You should get it as 84 liter. Are you getting 84 liter? Yes. Neeraj, Vamshi Krishna, Bhuvan. Yes. Neeraj, Vamshi Krishna, Bhuvan has answered it as D. Okay. So like this you have to relate. So from the equation, we have got these all things. So since for 156 grams of benzene, we require this much. So for 1 gram, how much? So they have asked for 39 grams. So what we have done, we have multiplied by 39. So we got 84 liters. Okay, we have got 84 liters. So option number D. Yes, everybody else is what also getting the same answer. Yes. Okay. Let us proceed further. An organic compound containing carbon, hydrogen, and nitrogen gave the following analysis. Carbon is 40%, hydrogen is 13.33%, nitrogen is 46.67%. What will be its empirical formula? What will be its empirical formula? Madan has answered it as C. Okay. Others? What about others? So here we have the elements. What is the element? Carbon is there, hydrogen is there, and nitrogen is there. So what is the percentage given? What is the percentage given? So this is 40%, this is 13.33%, and this is 46.67%. Right. Now what is the atomic number? Atomic weight of carbon is 12, hydrogen is 1, nitrogen is 14. So we'll take the reliable number. So 40 by 12. So 40 by 12, we get what? 3 point something. 3 point, then 366. Okay, it is 3.66. Then 13.33 by 1 is 13.33. Then 46.67 by 14 is again 14 number 14 3 0 33. Okay, so it is 3.33. So this is a reliable number. Let us take the ratio now. Ratio. So which is the lowest number is 3.33. So 3.66 divided by 3.33. Take the ratio. 13.33 divided by 3.33 and 3.33 divided by 3.33. So what is the answer? So here it comes 1. This is approximately 1. This comes to be 4. 3 ones are 3 fours are 12, 4 point something. This is 1. Okay. So the empirical formula is what? So it is C, H and N into N. So what is N? That is C, not N. So C1, H4 and N. Okay. So C4HN. So C. Yes, Madan and Neeraj. Yes, have answered it as C. Others, what about others? Got it? Everybody got the same? Okay. So like this, so this you have what you have studied how to get the empirical formula, right? In the theory, the same part. Okay, the same way, only you have got some 4 options here. So you have to tell the correct one. Okay, let us go for the next one. Hemoglobin contains 0.334% of iron by weight. The molecular weight of hemoglobin is approximately 67200. The number of iron atoms, atomic weight of iron is 56, present in one molecule of hemoglobin are. Yes, what all is given? First, the percentage of iron is given. That is 0.334%. Next, what is given? Molecular weight is given. Molecular weight is given of iron. That is hemoglobin. Okay. Let me write it at hemoglobin. I'll write molecular weight of HB. Okay, hemoglobin is how much? 67200. Okay. Then atomic, what is given? Atomic weight of iron is given. Atomic weight of iron is 56. Okay. Now, what all we know? We know that the number of iron atoms. How do we calculate the number of iron atoms? Number of iron atoms is molecular weight of hemoglobin, okay, divided by 100 into atomic weight of iron into percentage of iron. So we can use this formula. Okay. The number of iron atoms can be calculated as molecular weight of hemoglobin divided by 100 into atomic weight of iron into percentage of iron. So molecular weight of hemoglobin is 6722200. 100 into atomic weight is 56 into percentage is 0.334%. Okay, percent. Okay. So let it be like this only. How much you're getting? Okay, Madan, Vamshi Krishna and Neeraj have answered it as C. Just check. Are you all getting the same? So after solving this, you will get it as answer number C. Yes. Yes, Bhuvan has also got it as C. Okay. So yes, the answer is C. Answer is C. So C is the correct answer. Okay. Fine. Is it clear? Shall we move for the next? So till here, all the questions are clear, students? Yes. Are the questions clear? So we have solved some 15 questions now. Okay, let us move for the next question. An organic compound containing CH and O gave an analysis of, so the same question. Okay, you can take this as a homework if you want. Okay, so same question as we have solved previously for empirical formula. So I'll not again solve this. Same. So do the table. So for carbon and hydrogen, so again you have to write the percent, then take the real number, take the ratio, and write the empirical formula. Okay, let me tell you the answer. The answer is C. Okay, you have to get the answer it as C. So take this as homework. You can take a screenshot and you can do, you can solve this particular question. Okay, later. So you can take a screenshot and you can solve it later. Is it clear? Okay. So yes, so I'll move for the next question. The maximum number of molecules present in. So these are the 4 examples. Okay, so 15 liters of H2 gas as STP, 5 liters of N2 gas as STP, 0.5 grams of H2 gas, 10 grams of O2 gas. So you have to calculate which is having the maximum number of molecule. Yes, how do you calculate now? So we have to calculate the number of molecules. Okay, how do we calculate the number of molecules? So for liters means it is 22.4. So 22.4 liters at STP. Okay, at STP, that is standard temperature and pressure, it contains 6.023 into 10 raised to 23 molecules of H2. Okay, so this is the condition. So therefore 15 liters at STP contains how much? So cross multiply. So cross multiply, how much it will be? So it will be 15 into 6.023 into 10 raised to 23 divided by 22.4 liters. Just check how much you will get. Okay. Then second one, again same. So for 22.4 liters at STP, okay, I'll write like this directly. It contains 6.023 into 10 raised to 23 molecules of nitrogen. So for 5 liters, how much? So again, 5 into 6.023 into 10 raised to 23 divided by 22.4 liters. Okay, so this is for B option. This is for A option. Now check for C. So this is for gram. Okay. So 2 gram of hydrogen, 2 gram of hydrogen, because it is a hydrogen molecule. So hydrogen molecule means 2 grams, right? So 2 grams of hydrogen molecule contains 6.023 into 10 raised to 23 atoms of hydrogen molecule. Okay, hydrogen gas. So for 0.5 grams, how much? So again 0.5 into 6.023 into 10 raised to 23 divided by 2 grams. Again, calculate for this also. Lastly, for oxygen. So 32, right? So this is for 32 grams of oxygen contains 6.023 into 10 raised to 23. So for 10 grams, how much? So again, 10 into 6.023 into 10 raised to 23 divided by 32 grams. How much you are getting? Which is the correct answer? So which is having the maximum after solving? So you have to solve this, okay? You have to solve at each step. So how much answer you are getting and then compare it, okay? Which is the maximum? The maximum is in A. The answer is A. Maximum is A. Yes, Madan and Neeraj have already answered it as A. So A is the correct answer. So you have to solve this. So these are to be solved, whatever answer you are getting. So you have to compare. Yes, Bhuvan has also answered it as A. Okay, compare the all the four and you have to tell which is having the maximum. So I am getting A. A is the correct answer. Okay. Next question. The number of moles of KMnO4 that will be needed to react with 1 mole of sulfite ion in acidic solution is. Yes, the number of moles of KMnO4 which is required to react with 1 mole of sulfite ion is. So 2 MnO4 minus plus 6H plus 5 SO3 minus, giving you 2 Mn plus 2 plus 5 SO4 minus 2 plus 3 H2O minus 3 minus 2. Yes.
Option B.
Okay. Neeraj and Vamshi Krishna has answered it as B. So here you can see for the conversion of KMnO4, okay, to the sulfate ion, that is SO4 minus 2. So how many ions are involved here? Yes, it is MnO4 minus. So the number of moles of KMnO4 okay, that will be needed to react with 1 mole of sulfate ion in acidic solution is. So it is 2 by 5. Option number B. Yes, Madan, Bhuvan have also answered it as B. So it is 2 by 5. Okay, so you can see the coefficient. It is 2 by 5. Okay, yes, let us go for the next one. An organic compound contains carbon, hydrogen, and oxygen. Same again, empirical formula. Okay, empirical formula. Take it as a homework. Take it as a homework. And I'll tell you the answer. You should get A. A should be the answer. A should be the answer. Okay. Is it clear? Okay.
Answer A.
10 grams of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction will be A 3 mole, B 4 mole, C 1 mole, and D 2 mole. Yes.
B.
Bhuvan, Neeraj have
Yes,
answered
sir.
it as. Okay, let us see. So, hydrogen gas, okay, plus half O2 gives you H2O, right? So, for 10 grams, how many? 64 grams of oxygen were filled. Okay. So, a steel vessel was exploded. So, how much was amount of water produced in this reaction? So, 10 grams means it is 5 mole. Okay. And 64 grams means it is 2 moles of oxygen. Okay. So, in this reaction, oxygen is what? Oxygen is acting as a limiting agent. Now, already you have studied about limiting agent. Okay. So, oxygen is the limiting agent. So, the amount of water produced depends on what? It depends upon the amount of oxygen which is taken. Of oxygen gives how many? It gives H2O, which is 1 mole. So therefore, 2 moles of oxygen gives water 4 moles. Okay, so option number B. So for 0.5 mole, it gives 1 mole. So for 2 moles, how much it will give? Okay, it will give 4 moles of oxygen. That is water. So 2 moles of 4 moles of water. So 10 gram. So this is the limiting agent. So we know that whenever limiting agent is there, so it depends on what? It will depend upon what? So the amount of water, whatever the product has to be found, it will depend upon the amount of limiting agent. So here the limiting agent is our oxygen molecule. Is it clear? Yes. So I've tried to solve many questions. Okay. So yes, we have solved some 20 questions. Fine. So we'll see 2 more. So still 5 minutes is there. What is the psychometric coefficient of calcium in the reaction? What is the psychometric coefficient? Yes, of the calcium in the reaction. What is the psychometric reaction? So calcium, write the reaction. So calcium is undergoing what? It is undergoing oxidation, right? So 2 electrons, then Al plus 3 electrons giving you Al. Now here the number of electrons are different. So if I multiply it by 3 and this by 2, what I'll get? Then I'll get 3Ca plus 3Ca plus 2 plus 6 electrons. Now, sorry, here, okay. I should put a. Now here 2Al plus 3 plus 3 to the 6 electrons, giving you 2Al. Okay, now this and this get cancels. So 3Ca plus 2Al plus 3, giving you 3Ca plus 2 plus 2Al. So what is a psychometric coefficient? It is C. Psychometric coefficient means these numbers. Okay. So this is the psychometric coefficient. Yes, option number C. So Neeraj, Vamshi Krishna, Bhuvan, Madan. Yes, very good. Yes, answer is C. Yes, so this is about psychometric coefficient. Next question. The number of electrons in a mole of hydrogen molecule is. So how much is the number of moles? So we know that number of electrons. So the number of electrons in a mole of hydrogen molecule is. So number of electrons is equals to number of electrons per molecule. Okay, into number of molecules. Number of molecules. So remember this. So what is number of electrons per molecule? Into number of this. So number of electrons per molecule is how much? So hydrogen molecule. So it will give, each hydrogen will give 1 electron. So it will be 2 electrons, right? So electrons into number of molecule is Avogadro's number. 3 into 10 raised to 23. How much it is? It will come to 12 point something. So option number B. Yes, Madan, Neeraj, and Bhuvan. Yes, I have answered it correct. It is option number B. So the number of electrons in a mole. So whenever mole will come, you have to multiply it by Avogadro's number. Okay, fine. So this 1 gram of which of the following contains largest number of oxygen atom? Yes. 1 gram of which of the following contains largest number of oxygen atom? So you can see, if you consider 1 mole of oxygen, 1 mole of O2 molecule, 1 of O3 molecule. So in which you can see it will contain more. It will contain more in the, yes, C. Option number C is the correct one. Very good. So you can see when you have O3 molecules, it consists of 3 atoms of oxygen. So it is what? It is C. Yes, Madan, and yes, Madan has answered it correct. Okay, so option number C. So 1 gram of which of the following contains largest number of oxygen atoms? You can see in O3 you are having how many? 3 oxygen atoms, right? So it is the one which will have. See here in oxygen, oxygen atom, you have only, they have asked you largest number of oxygen atoms. Calculate the oxygen atoms here. You can see from here only, oxygen here is 1, here it is 2, here it is 3. So third one, largest number of oxygen atoms. Okay, fine. So we have solved some many questions. Okay, fine. So this completes. Okay, so this completes your chapter. Some basic concepts of chemistry. Okay, so I've tried to solve all the questions. Okay, from this particular chapter. Fine. Any doubts? Yes. So after this, okay, you will be having a test. Okay, so links will be sent. So please attempt the test. Okay, it will help you to know how much you have understood. Okay, and try to solve some papers. Okay, previous years question papers. If you have books, you can solve also to understand how much you are prepared. Okay, fine. So I hope you have today's class, whatever has been taught, it is helpful for you. Okay. Okay, so I'll be ending the session here. Okay, so we'll meet in tomorrow's class. Thank you. Test link will be sent in the groups. Okay, you are there in the groups, right? So in that only test link will be sent by 5 o'clock. So that time you can attempt the test. Okay, fine. So Yes, I'll add you. Okay, fine. Okay. Okay. Okay, thank you. Thank you, everyone. So I'll end the session here. Okay, we'll meet in tomorrow's class. Thank you.